Hi everyone, my name is Aitor Garciandia and I'm glad to present you my work titled Microservice-Based Performance Problem Detection in Cyber Physical System Software Updates. The motivation of this work is the following. Cyber physical systems are complex systems with a long life cycle, and software is continuously evolving during its life due to bug fixes or the implementation of new functionalities. The deployment is a critical point as the system starts interacting with the real physical world, and it's being done in a remote location in a resource-constrained environment, so reliability must be guaranteed. The heterogeneity of the environments and the high configurability of the software makes it impossible to test every possible condition in lab. And in this context, performance problems are more likely to appear as these problems are more difficult to detect due to the difficulty to establish proper performance requirements and the fact that these errors may appear only when the software interacts with the real environment. So, to overcome these limitations, we have proposed an approach to detect performance problems in software updates based on microservices. These microservices are deployed in the edge and are orchestrated from a cloud server. The method consists of two phases. A training phase, where the old version of the software is executed and the input data to the software and performance metrics are sent to a machine learning module. This module is trained with this data so that it can predict the performance of the new software version. When the training is done, the performance problem detection phase starts. In this phase, the deployer deploys the new software release and a performance oracle. The execution of the new release starts and the input data to the software is sent to the machine learning module. This module predicts the performance of the software based on its inputs and sends the prediction to the performance oracle. Actual performance metrics are also sent to the performance oracle so that it can compare the predicted and actual values and give a verdict of the system. If an error exists, an alert is sent to the cloud server. Well, the system has been evaluated in an industrial use case, which is the dispatching algorithm from Orona. Orona is a company from the elevation domain, and the dispatching algorithm is the piece of software which decides which elevator is going to attend each call in a building. The response time was the predicted performance metric in the software based on the number of active calls. Different training strategies have been considered by using theoretical data or real data from installations, and different machine learning algorithms have been evaluated. To evaluate the different algorithms, a performance mutation testing technique has been used, where we create mutants or faulty versions of the software and see if we are able to detect them. The results show how regression tree, ensemble, and TRGP show the best results, especially when training with real field data. So, the contribution of the work has been to propose a microservice-based method to detect performance problems on software updates and test it in a real industrial use case. In future, we plan to investigate the use of different data and training strategies so that real installation data is not necessary. Thank you.